volume and surface area. Now first thing we are going to start that what is area. Now we know that area of a 2D shapes. If we have a 3D shape, then it possesses volume and a surface area as well. Now what is surface area? We will discuss it later. But if we talk about area, then the shapes, the 2D shapes that we had studied so far, rectangle, and I am going to write the working formula as well. Now we all know that how our rectangle looks like. So that is a rectangle. We say that the length and it's the breadth. So area of our rectangle is L multiplied by B. And if we talk about the perimeter, that is represented by P. Now in general we say that perimeter is sum of all sides, right? Now if we apply this principle on the rectangle, so if this length is L, it means it is also L. If this is B, this is also B. So we have a total of 2L plus 2B. If you take 2 common here, so it will be L plus B. That is the working formula of perimeter of a rectangle. You should write it down, all the working formulas on your copy as well. Now after rectangle, the second 2D shape I am going to cover is a square. Now what is a square? A quadrilateral in which all the 4 lengths are equal is called a square. The working formula of area of a square is length square. Whatever the length is, the square of this length is the area of a square. And if we talk about the perimeter, so perimeter is equals to, there are 4 lengths and each length is same, so it is 4L, right? Now after square, moving on towards the next shape, that is triangle. You all know how a triangle looks like. If we talk about area, so area is 1/2 base into height, and the base is this total length, and height is always at 90 degrees. That is your height. So that is the working formula of area of a triangle. If you talk about the perimeter, let's suppose this length is A and this length is C. The values may be different, but the concept remains same, that perimeter is equals to A plus B plus C. That is the perimeter of a triangle. Now after triangle, if we move another shape, so I am going to pick trapezium. Now what is our trapezium? Trapezium is a quadrilateral with one pair of parallel sides. So our trapezium is a quadrilateral in which there is only one pair of parallel sides. If we draw the figure of a trapezium, so that is a general description of a trapezium in which these two sides are parallel, and that is our height. So randomly I am going to assign the variable. I am saying that this length is A and this is B. Now the working formula. So the area of our trapezium is 1 upon 2 sum of parallel sides multiply by height, right? And if we substitute the values that we suppose in our diagram, so it's A and B that are the parallel sides. So the trapezium working formula is A plus B times H. That is the working formula. And if you talk about the perimeter, so perimeter it's sum of all sides. So let's say I'm saying that if this length is L, so perimeter will be A plus B plus H plus L, right? So that is the working formula of a perimeter of a trapezium. Note it down and make sure that you write all the working formula at such place in your copy where you can find it easily, right? Alright, moving on to the next shape. The next shape is parallelogram. Now what is a parallelogram? A shape like this, right? This is a parallelogram in which this length and this length is parallel and equal. This length and this length is parallel and equal. So if I say that it represents the base and the height must be perpendicular always. The area of a parallelogram is base multiplied by height, right? And if you talk about the perimeter, that means sum of all sides. So you need to add all the lengths of the parallelogram to find out the perimeter, right? So that are all these shapes, 2D shapes we had discussed, and I had told you the working formula of all these shapes. Mostly shapes you had already studied in your previous class, I assume that, right? So after the area working formulas, if we talk about, before going to volume, first let us discuss the units of area. Now units play an important role in mensuration. Now area units are either it's meter square, either it's centimeter square, millimeter square. These are all the units of area, or it may be kilometer square, that is also area. You can observe that in area we have a power 2. That means there are two lengths which multiplied gives you the value of area. Now you can apply the strategy in all the shapes. If you talk about the parallelogram, you will see that there are two lengths. One is base, one is height. If you apply the technique on triangle, you have two lengths. two lengths, and if you talk about the rectangle, so there are also two lengths, right? In trapezium there are also two lengths. One, a plus b is the length and height is the length. So area is the product of multiplication of two lengths, right? Now after area, if we talk about volume, now volume is of 3D shapes. And what do you mean by 3D shapes? Let's suppose we have a cube. That is a small cube, right? Now cube is a 3D shape because there are three lengths involved in cube. Since it is a cube, all lengths are equal, so this is length, the depth is length L, and the height is length. Now there are three lengths, that means we are now dealing with the volume, and volume of cube is length cube, right? That is the volume of cube. Now in 3D shapes we don't have area, but we have surface area, and there is a short trick to find the surface area. First thing, as we had discussed in the topic arc length and area of a sector, right? Just a recall. In that topic I had told you that area is our friend, that is very easy to find out, and perimeter is our enemy because it changes in every question, right? The working of area in that topic was very easy because you need to apply the working formula, and it is same for all questions, right? The shaded area. But for the perimeter you need to highlight the shaded boundaries and then you need to add them together. So that is why I referred area as our friend, easy to find, and perimeter enemy because the formula is not fixed. Similarly, for volume, I say that volume, to find out volume is very easy. So we refer volume as our friend. You need to apply the working formula and you can easily get the value of volume. But if we talk about surface area, so like the perimeter, it's our enemy. And now you will get the logic why I am saying that it is our enemy, because its working formula is not fixed in every question. Now how you find the surface area? There is one short principle that I apply to find the surface area. Faces that you can touch. Now faces that you can touch in your mind will include for surface area. Let me give you an example here. Let's say I made a shape and that is a cone, right? Now listen to me very carefully. If I say that, can you touch this part of the cone? You will say yes. If I say, can you touch this bottom part of the cone? You will again say yes. That means these both faces will be considered for surface area. But if I make a cone and below that cone I will join another cone. Now if I ask, can you touch this area? You will say yes. Can you touch this area? You will say yes. But can you touch this area? So it's a no. We cannot touch this area because two faces are joined together. So that means if you need to find out the surface area of this shape, it will be only this one and this one. See the difference? So keep in mind, to find the surface area you need to visualize the faces that you can touch easily. And trust me, this is the most important technique that make your chapter very easy. Keep in mind, whenever you are finding volume, it's very easy. Just apply the formula and find the volume. Whenever you are finding the surface area, keep in mind, take a close look at which faces you can touch. If you can touch it, you will include it. If you cannot touch it, you cannot include it in the working formula. Right? Now, so if I say the surface area of that is our cube. That is cube. Now you see that in a cube it is a rectangle, right? Front and the back, right side and the left side, top and bottom. So basically we have 6 rectangles, and the working formula for area of a rectangle is length into breadth, that is length times length. So it's length square. That is the working formula for surface area of a cube. Similarly, after cube, if we talk about cuboid. Now cuboid is what? It is a rectangle in 3D shape. So let's say we have a rectangle and we need to make it in 3D. Now that is a cuboid, right? So we say that L, B and H. Now the volume is very easy to find out. You need to apply the working formula. And volume is what? It's length into breadth into height. Just multiply all 3 lengths and you will get the volume. If I talk about surface area, keep in mind the enemy part. Now look closely. At first, I am going to find out the area of the front rectangle, right? So the base is L and the height is H. So its working formula will be L multiplied by H. Area at the front and area at the back, they are equal. 2 identical rectangles, so it will be multiplied by 2. Similarly, if you take a look at the right rectangle, this one, so the area is what? Base times height. So area is base times height, and this rectangle and this one, they are same, so you need to multiply it by 2 as well. For the last one, the top face, if you look at the top face, so this length is L and this length is B, right? So area is L times B, and you need to multiply it by 2 because the top and the bottom rectangles are same, so it will be multiplied by 2. So that is the working formula of surface area of a cuboid. Make sure that you are writing all the working formulas in your copy. Now after cuboid, moving on to the next shape, that is cone. Now you all know cone very well, right? That is a general shape of a cone. In a cone, we have a radius from the center to circumference. We have a radius. This length, it is a slant height represented by L, and the straight line from the top to the center at 90 degree, that is our height. Now you see that I make a 90-degree angle with the red pen because I need your attention. Height is always at 90 degree. If the length is not at 90 degree, it might be a slant height, but the height must be always at 90 degree. Now what is the working formula of volume of cone? So volume of cone is 1 upon 3 base area multiplied by height. Now what is base area? The area that touches the base. If your cone is placed in such a way that the base is a circle, right? You have seen the caps mostly kids wear in the birthday parties. That is a good example if you want to visualize. So you see the face at the bottom is a circle, and the area of a circle is pi r square and height is h. So the working formula is 1 over 3 pi r square h. That is the volume of cone. Now since it covers the curved portion as well, so it has a curved surface area. Before cone we did not study the curved surface area because these two shapes don't have any curved length, but the cone has the curved length. That is why we need to study the curved surface area. Curved surface area. Now the curved surface area, the working formula is fixed. The curved surface area of a cone is pi r length. Keep in mind that this length is slant height. Slant height, right? Don't mix it with the height. Height should be at 90 degree. And one more thing I need to tell you at this step. You can see that we have a right angle triangle here, so we can apply Pythagoras theorem as well, right? In some question, to find the volume you need to find the value of height, and to find the value of height, length and radius are known, so you can find the value of height by using Pythagoras theorem. You need to remember, whenever you have a right angle triangle, you can apply Pythagoras theorem. Now after the curved surface area, we need to find total surface area. Now total surface area is what? It is basically the curved surface area, or you can say the faces that you can touch. If you see the cone, so you can touch this part, right? So this part is basically curved surface area, and you can touch the bottom part as well. So the bottom is area of a circle. So the total surface area, it will be curved surface area plus area of base. Now the curved surface area is pi r l plus area of the base is pi r square. And let me tell you again that this working formula is not fixed for every question. It depends on the question. Keep in mind that this is our enemy. So whenever the question asks about the total surface area, you cannot apply the working formula directly. You need to observe the figure that which faces we should consider, right? Alright, so after cone, the next shape is cylinder. Now the best example to visualize a cylinder is your soft drink cans, right? Pepsi, Mirinda, etc. So the best example is your soft drink cans. You can visualize it, right? So first thing about the front part, that means volume. If I highlight the length, so that is radius, that is height. Now the volume is pi r square h. That is the volume of cylinder. Since we have a curved surface in this, so the curved surface area, CS is the short form, curved surface area, that is equals to 2 pi r h. The 2 pi r means the circumference of the circle multiplied by height. The depth of the cylinder gives you the curved surface area. And if you want to visualize, basically when you are holding a Pepsi can, so the area that your hand is holding is the curved surface area, right? Alright. After that, the total surface area. Now visualize that if you have a can in your hand, which faces you can touch easily. Of course, you can touch the conical part from where you are holding. You can touch the upper portion of the cylinder and you can touch the bottom portion of the cylinder. That means the total surface area is equals to the curved surface area, that is 2 pi r h, plus upper portion, that is pi r square, plus bottom portion, that is pi r square. So it will be 2 pi r h plus pi r square plus pi r square, it's 2 pi r square. So that is the total surface area of a cylinder. I hope that you got the idea about the curved surface area and the total surface area. The curved surface area includes only the conical or the curved portion, but the total surface area includes the portion that we can touch easily. Again, I am just dotting it with the red pen so that you can remember that it is our enemy, right? It is our enemy. After cone, cylinder, we have one more shape to discuss, and the name of this shape is sphere. Now what is a sphere? The best example that you can visualize very easily is the example of a football. Football is a best shape of a sphere. I cannot draw it on the paper, but I will try. So it's not a circle basically. Sphere is sort of a 3D circle, you can say that. I cannot draw it on the laptop, but you can visualize the shape of the football, that is the shape of sphere, right? The volume of sphere is 4 upon 3 pi r cube. In sphere, the curved surface area or the total surface area both are equal, and it is equals to 4 pi r square. You can visualize it when you hold a football, so you can touch it easily on its entire face. That is why the curved surface area or the total surface area both are equal, and it is 4 pi r square. If you cut your football in two halves identically, So the first half, it will be look like this, right? If you cut your football, it will be look like this, and that shape we called a hemisphere. So what is hemisphere? Now you can say that it is half of a sphere. So the volume of a sphere is 4 upon 3 pi r cube. So the volume of hemisphere will be 4 upon 3 pi r cube, and you need to divide it by 2 because it is exactly half of a sphere. It will be 4 divided by 3 pi r cube multiply by 1 divided by 2. 2 and 4 cancel each other, so the leftover part is 2 over 3 pi r cube. That is the volume of a hemisphere, right? And if we talk about the curved surface area, that is the radius. So curved surface area of a sphere is 4 pi r square. For a hemisphere, we know that it is exactly half. That means it is equals to 2 pi r square. And last, if I ask about the total surface area, red point, keep in mind that this is our enemy. So in total surface area, we are going to include the curved surface area and the bottom surface area, right? So the curved surface area is 2 pi r square, and the bottom part is pi r square. So the total surface area is 3 pi r square. But keep in mind that these working formulas are not exactly applied in question. It depends on the question. It depends on the question. Keep in mind, volume, fixed formula, but total surface area, it varies. You cannot apply the working formula without observing the figure, otherwise it may be wrong, right? Now we have left over with the one more shape, and the name of the shape is pyramid. But we are going to cover the pyramid in the next class. So what you need to do, you must make a table. You must make a table like this, in which you can write all the working formulas, or if you write it in general like in the copy without the table, so it will be all right. Make sure that you write at such place where you can find it easily, and it will be very good if you learn all the formulas, so you can apply all the equations in the question easily, right? So in today's class, we had discussed in detail about the 2D and the 3D shapes. In 2D, we just find the area and perimeter, and in 3D shapes, we find the volume and surface area, right? Inshallah, in next class, we are going to continue with the pyramid. Till then, it will be good if you learn all the working formulas. So till then, take care and Allah Hafiz.